Hello students, today we'll discuss IB Physics SL paper 1, May 2019, time zone 2. No calculating this paper. My name is Neriman Melim. I'm located in Baku, and here you can see my mobile and email. To prepare for exam, you can use the following sources: main huge textbooks of Oxford 2014, short textbook by Tim Kirk of Oxford 2014, from examiner recommended to have IB Physics Guide 2016, but for sure you should have Physics Data Booklet First Assessment 2016, because clean copy of this Physics Data Booklet with formulas will be available for you at the exams. So be accustomed to this booklet, learn formulas from this booklet, and work easily with this booklet. This is the cover page. Let's start. Question 1. A student measures the radius r of a circular plate to determine its area. The absolute uncertainty in r is delta r. What is the fractional uncertainty in the area of the plate? Subtopic 1.2. If y equals a to the nth power, then fractional uncertainty are given this way. So we have formula for area pr squared. Pi r squared. Pi is constant, doesn't change fractional uncertainty. So we have n is 2 here, so we get answer A. Question 2. What is the unit of electrical power potential difference expressed in fundamental SI units? 7 fundamental or base SI units are kilogram, meter, second, Kelvin, ampere, mole, and candela. Subtopic 5.1. Give us formula of V equals W over Q. Current equals charge over time, or charge equals current by time. Subtopic 2.3. Work equals force times distance. Subtopic 2.2. Force equals mass times acceleration. So combining all these formulas, we get V equals W over Q, W equals F times S, or MAS, Q equals IT. Substituting the units, we get choice C. Question 3. The graph shows the variation of velocity of a body with time along a straight line. What is correct for this graph? First of all, this is velocity time graph. For this graph, acceleration equals gradient, and displacement equals area enclosed by graph and time axis. Let's check. A. The maximum acceleration is at P. No, maximum acceleration is somewhere here, where the graph tangent of the graph is the steepest. Average acceleration of the body is given by area enclosed by the graph. Absolutely wrong. The maximum displacement is at Q. So it moves one way and then returns. So it's not maximum at Q. Maximum displacement is somewhere here. It moved forward and then it returns back. The total displacement of the body is given by the area enclosed by the graph and the time axis. Yes. So here we have positive part above graph and negative part below graph. So choice D is correct. This total displacement of the body is given by the area enclosed by the graph and the time axis. Question 4. Two forces of magnitude 12 Newton and 24 Newton act at the same point. Which force cannot be resultant of these forces? These forces can be directed differently, and minimum is when they are opposite, so minimum is 12 Newton, and maximum is when they are in the same direction, 36 Newton. So possible force is in the range 12 Newton, 36 Newton. So not possible is A, 10 Newton. Too small. An object has a weight. What is the change in gravitational potential energy of the object when it moves through 8 meters vertical? Subtopic 2.3. Formula for change of potential energy. mg is weight. Here, attention, weight is given to 3 significant figures, but delta H to 2 significant figures. So answer should be given to 2 significant figures, which is minimum. And we get 4.888, and we choose 2 significant figures. It is B. So if we round, we'll get 4.9, so it is B. A boat with an output engine of 15 kilowatt moves through water at speed 10 meters. What is the resistive force acting on the boat? Resistive force will be equal to the force on the engine, and subtopic 2.3 power equals FV, F equals P over V, power 15 kilo by 10 give us 1.5 kilonewton, so it is C. Question 7. An astronaut is moving at constant velocity in the absence of gravitational field when he throws a tool away from him. What is the effect of throwing the tool on the total kinetic energy of the astronaut and the tool and the total momentum of the astronaut and the tool? Chemical energy of the body turned into additional kinetic energy when he throws the tool. So kinetic energy increased. Conservation of momentum. Total momentum, no change. So we choose answer D. Question 8. A table tennis of mass 3 grams is fired with a speed 10 meters per second from stationary toy gun of mass 0.600 kg. The gun and ball are an isolated system. What are the recoil speed of the toy gun and the total momentum of the system immediately after the gun is fired? Subtopic 2.4. Momentum P equals mv. Law of conservation momentum. Total momentum before 0, hence total momentum after is 0. Momentum of tennis ball after recoil is mass times velocity. Momentum of gun after recoil should be equal but opposite, as total momentum equals 0. So from relation between momentum and velocity, we find velocity equal P over m. We divide by mass, we get choice A. One extra 0 here. Let me check. So I'll take calculator. Also here you cannot use calculator. Divided by 0.6. 0.005, that's correct, right? So this is easily done, right? No problem. But here was mistake, now it is no mistake. Okay. Question 9. A block of weight W slides down a ramp at constant velocity. Friction force F acts between the bottom of the block and the surface of the ramp. A normal reaction acts between the ramp and the block. What is the free body diagram for the forces that act on the block? So because object moves at constant velocity, resultant force equals 0, forces are balanced. So in A, if we add force F and N, it should balance W, but it doesn't. F and N doesn't. So A and B are not the cases. What about C and D? So F and N approximately balance weight, but normal reaction doesn't balance the component of the weight perpendicular to the surface, so not C. So here force and normal balance weight, but weight doesn't balance normal reaction, so component of weight, yes, balance, sorry. Component of weight perpendicular to the surface balance normal contact force, so we choose D. Question 10. A substance changes from solid phase to the gas phase without becoming a liquid and without changing temperature. What is true about the internal energy of the substance and total intermolecular potential energy of substance where the phase change occurs? This is not about ideal gas, so potential energy counts. Intermolecular potential energy is increasing when molecules are farther. This happens in solid gas change. Internal energy is sum of kinetic energies plus sum of potential energy. As temperature doesn't change, kinetic part doesn't change, but potential part increases. Hence, internal energy increases. So we choose answer C, increase. Question 11. The temperature of a fixed mass of an ideal gas changes from 200 degrees Celsius to 400 degrees Celsius. What is the ratio of mean kinetic energy at 200 to mean kinetic energy of gas? This question is about accurate use of formula. Subtopic 3.2, average kinetic energy is proportional to temperature. So Kelvin temperature. So we change degrees Celsius into Kelvin. Kelvin here should be Kelvin. And 400 degrees into Kelvin. So ratio of energies equals ratio of temperatures in Kelvin. So we get 0.70, which is B. Question 12. A container holds 20 grams of argon 40 and 40 grams of neon 20. What is the ratio of number of atoms of argon 40 to number of atoms of neon 20 in the container? Number of atoms is given by number of moles multiplied by Avogadro number. Number of moles is mass divided by molar mass. Molar mass of argon is 40, of neon is 20. It is mass number. So formula for number of argon atoms is this formula, and for neon is this formula. We substitute values into this formula. So, and here should be n Avogadro. So when we find ratio, n Avogadro is cancelled, and we get 0.25, so A. Question 13. The graph shows the variation of displacement of a wave with distance along the wave. The wave speed is given 0.50. What is the period of the wave? So first of all, this is distance along wave, so we can find wavelength. So wavelength is 4 squares, which is 150. What else? Subtopic for 1 give us period equals 1 over frequency. For 2 give us wave equation from which we can find frequency. Frequency equals speed by lambda. Lambda from graph is 150. It is distance between maximums or minimums. So we find speed is given, so we find first frequency, and then 1 over frequency give us 3.0 seconds, which is C. Question 14. Object P moves vertically with simple harmonic motion. Object Q moves in a vertical circle with a uniform speed. P and Q have the same time period, T. When P is at the top of its motion, Q is at the bottom of its motion. What is the interval between successive times when the acceleration of P is equal and opposite to the acceleration of Q? So for Q, circular motion, acceleration is towards center, up at the bottom and down at the top. For P, acceleration is down at the bottom, at top, and up at the bottom. So accelerations are parallel only after half period and period. So after half period, P is up and Q is down, and after next time period, P is down, Q up, and so on. So we choose answer B, T over 2. Unpolarized light is incident on two polarizers. The axis of polarization of both polarizers are initially parallel. The second polarizer is then rotated through 360 degrees as shown. Which graph shows the variation of intensity with angle for the light leaving the second polarizer? So cross polarizers formula for values for different angles 0, 90, 180, 270, 360, we see that we have choice B. So we start with 1, then 180 is 1, and 360 is 1, and in between we have 0, so it is B. 16. Monochromatic light traveling upwards in a glass is incident on boundary with air. The path of the refracted light is shown. A layer of liquid is then placed on the glass without changing the angle of incident on the glass. the refractive index of the glass is greater than the refractive index of liquid, and the refractive index of the liquid is greater than that of air. What is the path of the refracted light when the liquid is placed on the glass? So here we have a situation when angle of incidence equals critical angle. This is why refracted ray goes along the surface. These formulas are not in booklets, so critical angle, sine of critical angle is 1 over n. So they are, but sine and refractive index are inversely proportional. Initial picture: ray falls at critical angle for glass air boundary as the refracted ray is along surface. So this is what we have without liquid. After we put liquid, in the liquid the ray is refracted away from normal. As a result, the angle of incidence is greater than here. But this is angle A. This angle A is more than critical angle of glass air, and also critical angle for liquid air, because liquid air has less refractive index. So here we will have total internal reflection, so light will not be refracted. So no refracted ray we have only in D. In the other cases, light goes through. Question 17. A student blows across the top of a cylinder that contains water. First harmonic standing sound wave is produced in the air of the cylinder. More water is then added to the cylinder. The student blows so that the first harmonic standing wave is produced with a different frequency. What is the nature of displacement in the air at the water surface and the change in frequency when the water is added? Nature of displacement. So it was node, it remains node, as you see in the picture. Node at the surface of water. Node antinode distance, lambda over 4, equals depth. With more water, depth and lambda decreases. According to this formula from 4.2 wave equation, frequency should increase. So for more water, frequency increases, but still we have node. Done. D. Question 18. A particle with a change in charge NE is accelerated through potential difference V. What is the magnitude of the work done on the particle? Subtopic 5.1. Potential difference equals work over charge. Rewriting for work equals charge by V. Charge is NE, so NEV, so we get B. The resistance of component X decreases when intensity of light incident on it increases. X is connected in series with a cell of negligible internal resistance and a resistor of fixed resistance. Ammeter and voltmeter are ideal. What is the change in reading of the ammeter and the change in reading of voltmeter when the light incident on X is increased? So when light intensity increase, resistance of X decrease, total resistance increase, current increases, but X and R are connected in series, so they share voltage of cell. And as resistance of X decreases, voltage on it will decrease. So this can be shown by formulas also. Subtopic 5.3 give us a potential difference equals I R plus R, right? So it is here missing EMF. EMF equals E R plus R, which is R total. So current equals EMF by R total. On the other side, resistance equals voltage over current. So voltage equals current times resistance. So if we talk about, right. So As I explained, total resistance when light increases or total decreases, current increases. Now let's find voltage on X. Voltage on X will be current by resistance, and if we divide by X, we'll get such expression. So as X decreases, error over X increases, so voltage decreases, as I explained. So A, ammeter reading increases, and voltmeter decreases. 3 resistors of 166 are connected as shown. The voltmeter is ideal and the cell has EMF of 12 volt with negligible internal resistance. What is reading on the voltmeter? So first of all, here we have 2 resistors connected in parallel. Their combined resistance is 3 ohm. 3 ohm and 1 ohm are connected in series, so total resistance is 4 ohm. Current will be 12 by 4 ohm, 3 amperes, and 3 amperes by. So voltage is measured across the 3 ohm resistance. 3 ohm by 3 amperes give us 9 volt. So to find combined resistance of 2 resistors in parallel, here you have formula, so you can look and add resistor 1 in series. Question 21. A horizontal wire PQ lies perpendicular to uniform horizontal magnetic field. A length 0.25 meter wire is subject to a magnetic field strength of 40 milli-Tesla. A downward magnetic force of 60 milli-Newton acts on the wire. What is the magnitude and direction of the current in the wire? Subtopic 5.4 give us formula. We write this formula for current. So we keep milli, and sign will be 90 degrees. So we get 6 amperes. Now about direction. Magnetic field is from north to south, so it is to the right. Fleming's left-hand rule. First finger, so take your left hand, close all fingers, open first finger and point it to the right. Now open thumb and point it downwards. Then open second finger, it points into the paper. So current is from Q to P. Done. So we choose B. Current we calculated from Q to P. A particle of mass 0.02 kg moves in a horizontal circle of diameter 1 with angular velocity 3 pi radians per second. What is the magnitude and direction of the force responsible for this motion? Subtopic 6.1 give us formula for force exactly, and omega is radian per second, so we get 0.0 p squared either C or D. Circular motion force is always towards the center, so it is D. Question 23. Which graph shows the relation between the gravitational force between 2 point masses and separation? So subtopic 6.2 formula. So GMM can be replaced by constant, so we have force times constant times some variable. They are directly proportional, so it is straight line through origin, so it is D. Question 24. A radioactive nuclide with atomic number Z undergoes a process of the beta plus decay. What is the atomic number for the nuclide produced, and what is another particle emitted during the decay? In beta plus decay, proton turns into neutron. Atomic number is the number of protons, so it decreases to Z minus 1 from Z. As beta plus decay is antiparticle, as beta plus is antiparticle with lepton number 1, it should be accompanied by particle with lepton number plus 1. which is neutrino. So we choose A, neutrino, and Z minus 1. Question 25. A position of stable nuclei are plotted by neutron number n and proton number p. The graph indicates a dotted line for which n equals p. Which graph shows the line of stable nuclides and the shaded region where unstable nuclei emit beta minus particle? Light nuclei are stable for n equals p. Heavy nuclei are stable for n more than p. So more than p, n equals more than p is C and D, not A and B. So here solid line is correct. Solid line is for stable nuclei. So we should consider C and D. In beta minus decay, neutron turns into proton. This happens when ratio neutron-proton is even greater than nuclei on stability line. So unstable nuclei by beta minus decays are coming closer and closer to stability line. Stability line, solid line, shaded line should be on the left, so we should have more neutrons than on stable line. The ratio. So it is D. So we choose D. Question 26. 3 conservation laws in nuclear reactions are conservation of charge, conservation of baryon number, conservation of lepton number. The reaction neutron turns into P1 minus plus positron plus antineutrino is proposed. Which conservation laws are violated in the proposed reaction? So charge, neutron 0, P1 minus minus 1, positron plus 1, not violated, 0 equals 0. In antineutrino, no charge. Baryon number, neutron is baryon 1, pion is quark and antiquark, baryon number 0, and no baryons here, so 0. Violated, 1 turns into 0. Lepton number, neutron is not lepton, pion is not lepton, antiparticle is lepton number minus 1, antiparticle lepton number minus 1, 0 is not equal to minus 2, violated, so C. 2 and 3 only are violated. Question 27. Which Feynman diagram shows the emission of a photon by a charged antiparticle? So at the beginning we should have charged antiparticle and then photon. Antiparticle direction should be opposite 2 times, so the only particle is here and here, and direction against time is for C, so we choose C, and here we have photon. Probably another particle is also antiparticle. Question 28. A neutron collides head-on with a stationary atom in the moderate of nuclear power station. The kinetic energy of neutron changes as a result. There is also change in probability that this neutron can cause nuclear fusion. What are these changes? During collision, part of momentum and kinetic energy transferred to nucleus. Probability of nuclear fusion increases with more number of neutrons. So it is choice B. Kinetic energy of neutron decreases. So kinetic energy should be conserved and part goes to atom. Okay. Question 29. 3 methods for the production of electrical energy are wind turbine, photovoltaic cell, fossil fuel power station. Which method involves the use of primary energy sources? Primary are not converted from another source. So first, wind, yes, primary. Second, chemical, yes, primary. Third, fossil fuel, yes, primary. So we choose D. All 3 are primary. Question 30. The orbital radius of the Earth around the Sun is 1.5 times that of what is the intensity of solar radiation at the orbital radius of Venus. So here you should know solar constant And solar constant is intensity of radiation falling on Earth. Subtopic 4.3, intensity is inversely proportional to the distance, where k, so I equals k over x squared. So ratio of intensities of Venus and Earth are equal to ratios of squares, inverse ratios of squares of their distances from Sun. So we can simplify it by putting square outside, and we put here 1.5. So Venus is closer by 1.5. So then we rearrange this for E Venus. So E Venus will be E Earth, which is solar constant, by 1.5 squared. So we multiply, we get choice D. Thank you very much. Paper is over. See you next time.